guys, greetings and welcome to my YouTube channel. In today's series of tutorials, in our quest for suitable environment, we should be looking into how to using our GIS, Geographic Information System, to maximize the available renewable energy resources around us. Okay, let's get into the work of today. The first one on our list is solar PV, solar photovoltaic, renewable energy, wind energy, groundwater analysis, crop soils, that's for agricultural purpose, recreation parks, getting the suitable area for recreational activities, and businesses, a good location to set up a new business or to expand an existing one. Okay, and now, like we mentioned, the first on our list is solar suitability. It's gonna be a long walk, it's gonna be a long journey, but I encourage you to just stick onto this. Believe me, it's gonna be fun, it's gonna be interesting, and it's gonna be educative. You're gonna learn a lot about how to model an area, suitability analysis, and getting the power output from your analysis, and as well carry out environmental impact assessment. Okay, so stick with me and let's do this. Now, like I mentioned, it's going to step by step be approach. We're going to start with this category, that is solar suitability, by getting our data, managing our data source, where we'll be getting our vector and raster data. I'm going to be walking around the downloading process and all that. That's in the next stage, followed by site suitability equation of a model that we're going to be using in a GIS environment to actually overlay all these criteria and attributes to get the best suitable location for the renewable energy in question. Okay, then after we're going to look at definition of weight. We're going to be using analytic hierarchy process, developed by SATE in 1988. Okay, so this method has been used by scientific researchers to define importance to multi-criteria, parameters and all that for several analysis. Okay, we're going to be using consistency ratio comparison to actually see, okay, the result we got from this important scale of importance, how reliable it is. We're going to be putting it based on the consistency ratio standard. Okay, and on that section we're going to be looking at pH weight from the normalized pairwise comparison matrix. It's going to be 10 criteria, so which is going to lead us to a 10 by 10 matrices. So from there we'll be able to get the weights for each of those criteria that we'll be using for our analysis in this section. Okay, then we move forward to suitability site selection algorithm. Okay, we're going to be developing an algorithm in a model builder to define the restriction model, build raster model for all these criteria, raster classification model weighted. Then we'll be applying the result of AHP to the raster there by classifying it. Then we're going to be doing weighted overlay model, then time and condition tool model to give us the final refined result for the suitability analysis. Then moving forward, we're going to be looking at the estimated solar energy production. Okay, now this is going to be interesting. We want to know the amount of energy that the area that we say is suitable for renewables can actually produce. Okay, now we'll finally look at the environmental impact assessment of the analysis build up together. Okay, now we're going to be looking at the criteria and what are these criteria that we'll be using. Okay, it's basically into 4 climatic, geomorphological, economical, and environmental. Okay, in each of these sections they have their own subsection or subgroup of criteria. Okay, in all we have 10 of them. So in this 10 going to give us the, like I mentioned earlier, 10 by 10 matrices that will be using a scale of importance to get the weight. All right, so moving forward, we're going to be looking at the solar data source, that is the PV data source and the downloading process. Okay, if you can see on this table we have the data source, the definition, and the some other parameters or attribute of the data. So you can see them, you can see their resolution, you can see what it means. You can pause this section, digest it, then we move further. So most importantly, we concern about the data source. Okay, I'm going to be walking you through how to get your data from SolarGIS and the kind of data you get there, your data from Google Earth Engine. All these are free source data. You don't need to subscribe into anything, you don't need to buy any packages. Okay, we're going to be looking at how to use Living Atlas GIS as well to download our data. Okay, on this quest, let's move forward. Now we talk about the formula or the equation that we'll be using for the suitability analysis in our GIS environment. Okay, by the time we get all these criteria refined, remodeled, then we can now bring them all together as a form of overlay in our GIS environment, and this is going to follow this simple equation. All right, it's going to be looking at the summation of the criteria and the weight and the product of the restriction. Okay, the suitable for, you can see what they represent, and we're going to be taking them one after the other in the course of this tutorial. Okay, in the next section we're going to be talking about the criteria ranking. Remember I mentioned that we're going to be using SATI. I also mentioned to you earlier that we're going to be using 10 by 10 matrices, and we're going to be applying a consistency ratio. Okay, the consistency ratio is going to follow this simple formula where this mass, that is EB value, and N is the number of rows and columns, and R is the random consistency index. I'm going to be showing you all this based on the formula as being defined. Okay, and that is for ranking. Then we look at the restriction model. Okay, restriction modeling is just about we defining areas using Boolean algebra to define the area that we don't want to tamper with, like let's say area that are so pressure that are already built, that are already existing, that we don't want to tamper with at all. Okay, and we're going to be using buffering basically in our GIS environment, and using some other tools to get the raster value. Okay, and in terms of build up area, we're going to be using 1 kilometer at buffering. That is, our analysis is going to start from after a kilometer away from a build up area like a burn area and all that. Okay, protected areas where like zoo and so many other factors like cross vegetation and all that forest, they are going to be excluded as well. Okay, we talk about water body. You can see in meter what we are going to be applying in this analysis. Okay, going forward, we're looking at the selection algorithm now. Like I mentioned earlier, we're going to build the raster model for all the criteria, raster reclassification model. We're going to be using 5 classes of reclassification. Okay, then we're going to be using weighted overlay method. All these are in Nigeria's environment. Then we move to what we talk about as well. All these are in baby step to step approach, so that I need to break them down before we move into the work in a GIS environment and all that. Okay, so all this we're going to be using this formula to determine the solar energy production of that area, okay, where the PAS stand for the yearly solar electricity production expressed in terawatt per year, okay, where SR is the yearly solar irradiation expressed in this unit, okay. Like for that location, what is the average yearly solar irradiation that going to derive from the data that we'll be using for that we use for the analysis, okay, because these results actually come after we might have done the overlay and the final analysis, the final result being output, okay. The SA is the total area of suitable location expressed in kilometer square, okay. And then we move to AF. The AF is the percentage of total area that solar panel could cover in percentage, okay. Out of this area that we've found out to be most suitable for solar renewable energy, we're still going to narrow it down to a certain percentage that are suitable, because in reality it's not all the areas that are going to be suitable for solar renewable energy. So we, like say 50, say 40, say 20 of this total area is suitable for renewable, then we now bring it down to further process on the 20, okay. And then the efficiency in PV system, that is the technology that will be implied. The efficiency of the technology will also be used as part of the parameter for the analysis or for the calculation, all right. And then finally we going to do environmental impact assessment. Yes, now like I mentioned, it's going to be interesting, it's going to be fun, you're going to learn a lot from this. I encourage you to stick to the end of this tutorial, all right. Now you just grab a cup of coffee and let's do this.